for sprites and some tiles, and that's all. But I will use sample codes from time to time. I'll take snap of the code from time to time. So let's start. I will don't handle the installation of MSXgl because well, you know how it is and it's very simple. But I will start by duplicate the MSX1 templates. And let's call it Pisa. This one is not necessary. Okay. We are under Windows, so don't need this. Okay, so you have your main program, the MSXgl library configuration, and the project configuration. So let's call it main or Pisa. And we'll start by changing the configuration of the project. Oh no, okay. Let's create a workspace. Okay. Oh, that was a previous project. Okay. This is a new one. And okay. So we can change the name of the project. This is important because you can change the name of the segments.
Okay.
If you want. But just to make a prefix, for now you have to follow the coding, the naming convention. It's name, segment number, bank number. Library, we will add the V999 because we are making a game for this platform. MSX, it will keep with MSX1. And just for fun, we'll use the Neo 60 mapper because it works on the MSX Pico and on the emulators, so we can try it. RAM size is default 128, I think. We can keep that. Signature is needed. This one is important. As we will use the V99 as a VDP, we need to use the interruption from the VDP to synchronize the gameplay. So we'll use this. Okay. You can give a nice name. Okay. Let's call Pisa Devcon. Okay. I think we are good. We can try to compile. Mapper type and the size and everything. Okay, nice one. So as we and the size and everything. Okay, nice one. So as we use the V990 interruption, we have to define some function. And this is a 3 function we need to define. It's on the documentation. This one. This is all the project option. Open. Oh, we have a problem with internet. it's coming, I hope. Okay, it's here. So, okay, so is a custom ESR is for interruption handler, and for V99 we have to define those three functions. So we can add it to the code. Okay. So for now we can keep them empty. Okay. When an interruption, forgot the definition. Void. Okay. So when the V99 interruption will occur, they will they will search this function. They will be called, and as it's empty, just return and continue the program. For now. So now it should be okay. Good. Okay. So I configure my project to launch OpenMSX to test. After we'll try on the real hardware, but let's start with emulation. That's not good. That's not good at all. Why? Okay. I should have made something first. When you get new projects, first try to compile it before changing. So I canceled all the modification I done here. Yes, just to be back to the beginning. It is always easier to start from something that works and then iterate. And when you have something that don't work, you know where you have made a mistake. Okay, so this is okay. So let's call it Pisa. Okay, sorry, Pisa.
Sì, ci sono già implementate, ma non è una
Sì.
ha ascoltato il video cooperativo.
I will put this option to false, so the library will not be built again.
Okay.
But we have to be careful. It's really quick, but if you change something in the library configuration, you have to rebuild the library. But while we don't, it's quicker to just...
Non forse più la creazione delle via stante.
Okay, so it still works. It's my pisa.ram. So where is my mistake? Let's... I think it's not this. Okay, I need this one. Okay. What I did? Okay. Let's start with more common formats. Okay. And as we can see here,
lo compilano.
Sì, nel senso compila, non dà errore, ma non parte. Ora ha messo quella corriente.
Okay, I understand. I use V999 interruption, but I didn't configure the V99 to trigger an interruption, so it's stored. But I will start with a standard. I will use the MSX to synchronize first, and then we will move to V99 synchronization. Okay. Wait. So this one is for MSX. And this one is for V9990. Okay.
Non necessariamente
Ha aggiunto una funzione? Ok, no, mi ricordo.
We have to add setup to initialize the V99, but we do it after. Just try it.
Inizializzazione.
Okay,
Ora è la prima.
everything okay. Now, just change the title. Okay. In fact, we will not use MSX display at the end because it's a V99 game, but I think it's interesting to display some information. So yes, you can follow if there is an error or something like that. So
It's possible to open MSX.
what?
If open MSX emulator, it's possible to
To switch? Yes, I will show you. Okay. Okay. So the first thing we can do is to detect if we found the card, the V990 card. Yeah. For that, I will open the V99 sample because there is a lot of examples. So let's add it to the workspace. Okay. So now we have access to all the MSXgl engine and projects. Samples, and we are looking for this one. Okay, so it's a sample that showcases all the screen mode, but the one we are interested in is P1. P1 is, I can show you. P1 is... just a minute. Okay, P1 is this mode. So you have, it really looks like the MSX tile mode because it's also used 32 tiles and 26.5 tiles. Yes, you have half tiles, and each tile is 8 by 8. But the very good thing is you have 2 layers, and also you have 16 color per pixel. So this is what makes it very cool to create a game. So this is the mode we use. And in this sample, if I follow this one, I will arrive to the initialization of the P1 mode. So I will copy that on our project. Perhaps I can create a function. Initialize the okay. Okay. And we'll call it here. Oops. Okay. So this one is to select the mode. This one is okay. This one is to hide the screen. It's just a matter of displaying cleanly, but we don't need it for now. This is to disable interruption, so we don't want this one. Okay, it's to set the background color. everything will work with palettes, so we'll have to define our own palettes. And this one is to use the sprites. So, okay. So first we can use the v99 interruption.
Okay.
So to do so, we will use this function, set interruption, but not using none. Okay, if I... the documentation is here, okay. Okay. If I search for this function, you can define which interruption you want. For now, we only want the vertical one, so it's a interruption that the v9990 send when the screen display is finished. So when you reach here, it sends an interruption, and we use it to synchronize the gameplay. But you also have an interruption that can be sent at the end of each display line, and a very useful one is this one. You can have an interruption when you start a command. Command is, for example, copy some data, and when it's finished, you get an interruption. It's very cool.
Ok, secondo me link da presentazione.
So we want this one. Okay. So now I think we can move to v99. Okay. Okay. Oh.
Okay.
Beginner's mistake. Okay, I forgot to add the module includes. Okay, that should be okay. Okay. I think I have to rebuild the library. Or did I make some mistake? Q1, debug sprites. Okay. Sorry. Yeah, I revert all the modification I made. I will keep compiling the library for now. It's a little bit slow, but while we are iterating in the configuration, it's better.
Quando fai il build, quella libreria che si chiama
Se no, quando modifica la JS, praticamente questo,
Okay. There is something missing. What did I do? Okay, we check the sample. So in the sample, we did that, okay. And the interruption handler. Okay, nothing special. Explainable interruption. Okay. Display true. I don't think it's the problem, but anyway. I think in setup it should work.
Ok, grazie.
We have 10 minutes? No? It will start now? No. Okay.
non ho scelto perché non tu sai che fa presenza.
Io prendo ancora invece.
Okay. If you want, I can debug the problem, and we'll continue after the niches conference. I will just debug, and I will come just after.
Ok, a me mi piace.
You stay here.
Yeah, but I will come to the conference just
Ok.
when it works.
And we are finished.
Yeah?
I
Put it
I
here,
leave
okay.
here my phone.
I'll take it with me. Oh, it's okay. I can. Or
Sapete? Un cammino. Sì. No, ma sono vecchio.
oh. So
Okay.
Ok.
that was a stupid mistake. Just this line. In fact, the internal VDP was sending interruption,
Okay.
not just the V9990. So this VDP was blocking
Okay.
because no, not conflict, but in fact, when an interruption is sent, if you don't handle it, it will still send it any frame, anytime. So we have to disable it.
Okay.
So
Clear.
just using this function, just using this function, and here we go. Now,
Perché quello che interno è in conflitto con la
Non conflitto,
No.
perché arriva uno poi.
Ok, arrivano su questo.
if you want to have a synchronization, you need only one signal,
Okay.
and you have to handle it, so it will go away until the new frame. So now we have, it's working. So it's still on the MSX side. So now we can convert the data and display it on the V990.
Okay.
So to do that, I will copy I will copy my data here. Okay. And I will convert using a batch, so we can do it. Okay.
MSX Major.
Yes, MSX EMG. Build data, for example. But okay. I will use the base of another project. Sample. Some. And this is a script I use to all the data I have in the samples. So there are a lot of examples of conversion. If I want an example of V990, I can go there. And I will copy this line. Okay. And now,
Che ti mandavo anch'io la nostra, i tiles e
okay, I need some setup. I think this will be okay. This is just to set up the folders. But I think... Okay. So from the project, this is a link to the tool directory, to the MSX TK toolkit, binary, where is the MSX EMG. And this one is not needed. And this is where I want to put my final data, so my .h. And I don't need this one. Okay, so I will convert my image. So name is is here. Okay. We will start with a character. Let's go. Let's start with the character. Oh, with style sets. This one. So the file name is here. Okay. This option is just to include the license of the image, because I use free data. I like to have the contributor name. So I need one file. Let's do it cleanly up. And I need this file. But it's not mandatory. It's just to show you how to do. This is a final name, the name I will use in the program. So let's call it style sets. The start position, where to take the data. So this is here. I think it already is a good place. So X is 0 and Y is 128. So this is right. This is the size and the height. And the height is 32, I think. Yeah, 32. So we have 4 lines of tilesets. So I have to change this. This is not needed. This is the name of the table. The tileset. The transparency color. I use magenta. You can use what you want. The number of bytes per color, so 4 bytes. So you will have 2 color per byte. And this is to to build unique palettes for the tiles. Okay, let's try. Okay, so now I have a directory called that's not good. That's not good. Where is it? Anyway, I will clean later. So now it should be okay. Okay. Oh, no file inside. Ah, GK is GK is okay. Content. No. Source data source. Okay, this file is also here. Okay, that should be okay. Okay, success. And this is for the the license, and we have our table. It's 4K, and if you calculate, so we have 256 pixel, but as one pixel use only 4 bytes, we should have half, so 128 bytes for one line, and 32 lines. 32. No. 32 lines, and it's 4K. So we are good. And we have our custom palettes.
Quello dove non tornava un discorso, è quello poi bisogna lasciarci.
So we can include this file now as that data.
Okay.
So it's in contents and data. No, I don't remember. Tile sets. I am set. Okay. Just check that everything okay. Oh, fine is not. Time. Oh, I made a mistake. Tiles set. Okay, I will fix the batch. This is error. Okay. Should be okay. Okay. To speed up the test, we can activate the option to don't recompile the library. Okay. Okay, here we are. So now what we want is to display this data on the V990. So, okay. We are still not using. Okay. We don't need this one anymore. We only use interruption from the V990. Okay. And after that, we will load our data. So we have an example here in the sample. So once again, I'll search for P1 mode. Okay, this is here, and this is how we can load data. So it's like with default MSX VDP, you have a place in VRAM to put the patterns, and you have a place in the VRAM to tell each cells which pattern to use.
With soft sprite and use the memory. I use the memory of the
VDP?
VDP
Okay.
For the software sprite.
Okay.
And it is possible to change the address of the tables.
On the V990, not for the. I think there's only one table you can move. I will show you later. But for the pattern, it's fixed.
Ok.
Oh, thank you.
Sì, io sì, ce l'ho. Non mi... Sì, ma l'ha dato un vedo. Guarda che non mi hai mai dato la tessera. Non so, ma mi hai dato...
So, this is a constant to tell where we are supposed to copy the patterns, and it's address 0. And this is the data we want to copy and the size of the data.
Ok.
And
L'array e la sequenza.
Questa è la base.
Sì, base.
And the problem is not a bitmap mode, so you don't display what you have in VRAM, you display tiles.
Ok.
So I will do something simple. I will put unique tiles on each cells of the screen. So it's like a pseudo bitmap mode.
Okay, yes.
It's just to show you how it works. So we will do a loop or a for loop.
Sì, infatti il P1 e il P2 sono quelli che si avvicinano di più. E la modalità P1 e P2, dopo la modalità P1 e P2, le altre sono troppo P1 e P2.
Okay, so I will set for each cells a unique index. So this is the size of the screen in cell size, and so you will just have to poke.
In tile size.
Says yes,
Okay.
tile is the size, and I will use this. I will use this function. Okay, I will explain just after, and this one. Okay. So the first one is to
I understand. Okay.
is to know where to know the address in the RAM of a given cell's position, because it's 16-bit index. So the first index is the second index is 2 bytes after the first, and to make it simple, I create
in base of the site, the tile site, with this function cell address P1A, I can get the address of the VRAM.
Exactly. So
praticamente gli dico questa tile, gli dico qual è XY della tile, gli torno l'indirizzo RAM dove devo andare la scheda video, dove devo andare a scrivere, poi uso il default con questo indirizzo RAM. Cioè, io sto cercando tutti i tile. Con questa funzione qua, gli do che tile è, lui mi dice guarda, questa tile se vuoi in questa posizione, sapendo che dimensioni ha, dice guarda, in questa posizione corrisponde a questo indirizzo nella VRAM. Dopo quando hai l'indirizzo della VRAM vai a fare il default. Cioè ti torna l'indirizzo in cui la tile, senza sempre stare a calcolare tutto.
You just put the right number at the right position, so it will be 0, 1, 2, 3, and so on.
Lui dai solo la posizione della tile, lui ti dà l'indirizzo in cui devo scrivere nella memoria.
And I think it should be enough to display the image, but let's test. So I configured. You can change the display of the screen. It's video, and it's here. MSX is for internal VDP, and oh, okay, and Okay, it's just because I have to change something in the configuration to tell OpenMSX I'm using the V9990. Do it now, and this is here in the emulation section of the configuration. Just tell I want to use V9990. Okay, and now it will change the command line. We can see here. This is how I call OpenMSX, and now it added this option, a new extension, GFX 9000. So, okay, so it's automatically switched to the V9 display.
Okay.
But I can come back to MSX. Okay, and you can bind. And for example, I bind the switch to F6. So press F6 and I can switch. But it's not working. It's not working. Okay.
Ma questa è la
Forgot
20, tra
something.
l'altro che c'è tutta la roba di calcolo incorporata. Hai notato la 20 c'è quella barra sopra? No, la carta la 20 è così.
Perhaps it's working, but you can't see it because everything is white. But if I change the palette spread, perhaps it will work. So you have an example here of setting palettes. So you have a function, this one. Okay, here. Okay. This is the first index, then the number of colors, then the data. So here. Okay. And perhaps it will work.
And now,
Okay. Hallelujah. What is interesting is you can see the yellow strip. In fact, it's the data in the second layer.
okay.
Yeah, it's why you can see them through the peaks here. So the tiles start from 0. So we have 0, 1, 2, 3, and so on. The second line is here, third line, first line. So we have no data after. So what we can do is to say the tiles 128, this one, the one below the others, will be blank, and we'll use it to blank the screen because there is no data here. So what we can do is just do the same thing. So we this is will for the first layer, and we'll do the same for the second layer. And the layer is called A and B. So now for B, at the same position, we will set always the 128 tiles, and it should blank the screen. If it's really empty, but I think it's empty. And it's not empty. Okay, but because we didn't clear the. Okay, let's clear the second part of the VRAM.
Second layer.
Yes. So we don't use write but fill. Just to put one.
Only one
Yes.
tile for all.
Yes, and we will put 0. And don't know. Let's say.
Okay. Vabbè, adesso la vuoto sotto, sarà tutto nero adesso.
Da 0
4096.
Okay, what's going wrong? Anyway, we will copy different data there. Something F. Okay. Let's do this. Okay, understood. So we have the two layers, and I think the yellow strip is the default value of the VRAM.
Ok.
So it spread all over the screen, and we clean the B layer.
Ok.
So I think it's okay, but we didn't clean the A layer. So after the data we copy, the remaining of the VRAM still show the yellow.
I ask if I understand. There are two layers.
Yes,
And the first layer, I have the tiles.
I copy,
But also
but only I just copy 4K. So it's just the upper part.
Okay.
So it's clean, but the remaining. Yes.
After the four tiles,
Yes.
I have the default on the layer.
Exactly.
Sì.
So
Invece ho due layer, dove ho messo solo delle tile, però giustamente sono anche su quel layer dove ho messo le tile c'è il default che sono le cose gialle. Deve togliere. Per me invece è pulito il secondo layer, invece deve dire no, togliere anche il default.
So we'll clean both layer first.
Ok.
B.
Adesso anche lì se le vuoi, sono due layer. Dopo anch'io devo dire
It will take longer. What is
Lui ha pulito
it?
tutti e due i layer e poi ha messo le tile, però lo stesso rimane.
Okay. It's my fault. I cleaned the layout table, not the pattern table.
Ah,
Okay. So I have to clean the remaining of the screen. So from here, I will put 0. It's 8 bits copy, just 0. And for the whole screen, so it's this is the whole screen.
ok.
But has 1 pixel, 2 pixels are inserted in 1 byte. I half this by 2. Okay. So now the pattern is clean. Okay. And this is the layout is also clean. This one is to clean the pattern table.
Okay, yes.
And this okay.
Pattern and layout.
Yes, exactly. Clean layer A layouts and patterns. Okay, so let's move it here. In fact, I don't need this because I set each layout's value here. So I don't need this one.
No, you don't understand why?
I don't need to clean the layout table because
okay.
I set it just after.
Okay.
What I need to do is just to clean the pattern.
Okay.
For the first
of the same layer, the
Yes.
pattern and the layout of the same layer.
Yes.
Is not need to clear the second layer.
I need to clean the pattern, or at least I need to clean the pattern, one pattern, and then use this pattern everywhere. But it's simple to just clean everything. And this one is also not needed, I think. Okay, I will keep this one. I will keep this one. Oh, it's okay. It's okay. Let's go.
The yellow strip is the default.
What?
The yellow strip are the default.
Yes, but perhaps it depends on the cartridge.
Okay.
It's not. You don't have to rely on this. Just clean everything and. Okay, so here we are. Finally. Now what we can do is load the background on the other layer because I prepared another image. Yeah.
Wow.
It will be used as a bitmap. So I will keep the one index per tile layout, but we will use this as background.
Sì?
Quindi la 1 lui la usa come appoggio per le taglie, la 2 la usa per prendere le taglie e mettere al background.
Sì.
So I just
Come una sola bitmap anche volendo. Vediamo farlo come una grossa bitmap. C'è fisso.
so I duplicate the line to export, change the input image file name. Position will be 0, 0. So I want all the image. So yeah.
È come una grossa bitmap.
Però questa qui per
I don't need transparency.
Questo è preso dentro un altro file, fa una grossa take, grosso come tutto il taglio, grosso come tutto lo schermo, e butta dentro.
I keep the 4 byte per pixel and the custom palettes, but no transparency. Anyway, in this mode, we can't use more than 15 colors because you always have a transparency color. You need to have index 0, it's always transparency. Nothing to do with it. When you are using bitmap mode, you can use all the 16 color, but not in P1 mode. But anyway, okay. So now I have another data. Yeah. It's a big data.
wow.
Yes. So it will not fit in a 32 cartridge. So let's move to Neo Mapper.
Okay.
Yeah. So the configuration file is here. No, Neo Mapper is. I will show you. It's a mapper. Okay.
Where can I buy the new mapper?
The MSX Pico. There is a guy that's selling MSX Pico. I think he's a Dutch guy. Yes.
Dutch, Dutch.
Yes.
Yes. The same person which produced the keyboard
Yes.
adapter.
Yes.
MSX che produce gli adattatori della tastiera, lo conosco.
This is this guy.
I know.
Yeah, it's a very great cartridge. It's only have a small drawback. It adds some wet states when we connect to the VDP. So you can't use 100% of the power of the VDP, but anyway, I think all game works with this. But for me, who likes to use 100% of the power, it's a little drawback. But except for that, it's very cool cartridge, very easy to use, and you can update the firmware easily. So very great hardware.
I will buy.
E spendi.
So,
Sempre meglio che con la donna.
so for the mapper road, so the basis is okay. Let's start with standard ROM. In a standard ROM, for example, 30K, this one, in MSX, the CPU can only see 64 kilobytes at any time, never more. So the trick is to change what you see. And this is the slot purpose. And so for a normal cartridge, you have, for example, 2 pages of the memory space, so address from 400 to C00, that are always seen by the CPU.
Okay.
But the drawback is you only have 30K of space to put your program in. And often you use the upper page for RAM, for memory, to put your variables and so on. And the lower part, this is the more common setup. And the lower part is set to the main ROM, the BIOS, so you can use the BIOS functions. So this is for what we call plain ROM, and the other type is mapped ROM, most known as Mega ROM, but Mega ROM just mean 128 kilobytes. But we can have bigger or even smaller. You can have a mapper ROM of 60K, 64K. So I prefer to use mapper ROM. So this is almost the same setup that before, but the difference is you have indirection.
Yeah.
You don't see the contents of the ROM, but you have banks that select what segments of the ROM you see through each bank. So this is a ASCII 8 mapper. And
ASCII 16.
And the Neo have 2 different improvements.
Okay.
The first one is you can use 60 bytes index for your segments. So it means you can have larger. Yeah. Okay. So now I only use 12 of the 16 bits because we wanted to have something that can be improved later. So it's why you can have cartridge up to 36 megabytes. But if we want, if we for example use 2 more bytes, we'll be able to have 256 megabytes. But I think 64 is quite a lot for MSX.
Okay. I just learned to use ASCII 16,
Yeah?
and now I will try to learn.
It's almost the same thing. The two difference, it's index, it's 60 bits, but in MSXgl, it don't change anything for you because you use the same function and the library take care of everything. And the other difference is you can select your mapper in the page 0. And it's a big difference for programmers because in 60 kilobytes, you only have 2 pages, so it's very difficult to switch. But now you have 3 pages, so it's very easier to switch. Okay, I will show you how to do. So I have selected Neo 6, and hopefully it will work. Okay, still works. The difference, if we check debugger slots, okay. Now we can see in the page 0, 1, and 2 we have the slot 1, and this is a cartridge slot. So my cartridge is visible in all the page. except the fourth one, that is the memory. So we have 40K of continuous memory, and we have 3 bank. We can switch to any of the segment of the ROM. So what we can do is to put the new data we created in a new segment. I think it's important to keep tracking of what data you have in which segments. So I will put a comment here so we can remember. So for example, page, okay, not page, segment. 0. 1, 2, 3. Oh, 3. And contents. So the setup of the ROM, it can be disturbing because you can see we have bank 0, 1, and 2, but this is not the same order in the segments. This is because we need the ROM header to be in the start of the ROM. It's not needed for the MSX, it's needed for the tools. For example, when you flash your game, they will search the ROM header.
Okay.
So you have to have it at the beginning of the file. So it's why I put the header in segment 0. But in fact, MSX search for header only in page 1 and 2. So your header have to be here and here. So I choose to put it in the more common place in bank 1, page 1. So segment 0 will be placed in bank 1. So segment, bank, content. So it will be in bank 1, and the content is our program lower part, lower 60K part. Okay. Then the segment 1 will be the upper part of our program, like in bank 2. Bank 2. Higher parts. Okay. And our segment 2 will be the content of bank 0. And so in page 0. Page 0. It's also a program. Okay.
We make a map in your commented map in your project for.
Yes, just to remember. Yeah.
Okay.
And so, for example, we'll use the segment 3 to put our new image. So we have to think where it will end up. So, for example, as we have 48K of linear memory, I will use bank 1 and bank 2 to my program, and use bank 0 and bank 1 to my program, and use bank 2 only for data. So we can switch easily. We have 30K for our program and 60K for the data. So first problem, you will see data is bigger than 6 kilo. Where is it? Here.
You must
Splits? No. I will show you another way to do that. But let's continue. Okay, so it will be in bank 2. Oh, bank 2. So this one will not be used for now. Okay. But bank 2 I will not use for program. So if we want, we can put data later on. Okay. Not use. Okay. So this is the height part of the program and the lower part of the program. And this will be background image. But as it's bigger, it will span over two segments.
Ok, sì. Se lui butta tutto in quella lì, tanto poi spanna in quella dopo. Quando è troppo largo. E non sta a
Proprio
dividere.
passi il link del segmento, lo vai a scrivere in
Lo va a
quello
spannare in
successivo.
quello successivo. Di conseguenza non separa il file, ma tanto sì. Naturalmente si deve ricordare che la parte di spannata non usare il file.
Se no va a scrivere i dati.
A parte poi te lo dice non più.
Ah, okay. So I have an idea. Before doing that, we can just move our current data here. So we can use this one to put the tilesets,
Ah, ok.
tileset image. So I will show you the standard way of adding data to your mapped ROM, and after I will show you another alternative way. So if I want my data to be specific in a specific segment, I can create a source file with the right name, so it will be load at the put in the right place in the ROM. So to do that, I just have to create a new file. Okay, so I will duplicate. Oh, okay. Create a new file. Call it Pisa bank or segment? Segment? I think it's segment and bank. So segment will be 2. No, 1. Segment 1. And bank will be 2. Let's see. So it will be there. No, sorry. It will be there. Okay. So segment 1 go to bank 2. Segment 1, bank 2. Okay, we are okay. So all I have to do is to include the data. So I will remove this one. So it's no longer in the default program. By the way, I can also, okay, let's move everyday data. So we have really 30K only for program. And I will put it in my segment source file. Okay. I need to include include MSXgl to have the type U8, something like that. Okay. And it should compile. It should not work, but it should compile. Just check it first. Okay. So we move data, but the main program have to know about the data. So we have to, yes, declare the external. Yeah. So we need this one, and this one. Okay. We can put it in the main program, for example. It's a definition. External data. Okay. Okay, and for the fonts, well, I know the name. It's just this one. The compiler just need to know what is the type of this label. No, you have to know this label exists somewhere and what is its type. And for example, this one is char. And this is the only thing we need for the compiler to be happy. But if we use the size of directive, this one, you also have to know the size. So, in fact, I will add an option in MSXgl to generate a separate file with only the definition and the size. But for now, just keep it simple and I will put the size here. Oops. And that should be okay. Now. Oh, okay, Sam. Thank you. Okay. Okay, but it will not work because I have to switch. Oh, no, okay. I said nothing. In fact, they copy the tiles, and this is the fonts. This is the font data display as a tile. But anyway, it's not a problem. It's because we copy too much data, I think. But no, I will check the MSX side to see if the font is working. So okay, so the font is working. So everything is okay. It's because by default this segment is selected in bank 2, so everything is okay. But when I will have more than one segment I need, I will say which segment I need at a given time. And for that, we have a macro I can show you. Program samples.
E i dati per i dati funzionano in esatto modo come funzionava per gli altri master.
So we have a different function to set which bank is visible in. Now each segment is visible in each bank, and I will use this one. So you tell bank 0 puts segment 4. Okay, so I have to put it where I use the data. For example, here is where I use the fonts. So, it's working already, but I think it's always better to select the right segments. For example, here is I will select segment 1. No, bank. Yeah. Bank 2 will point to segment 1. So bank 2. Okay. Segment 1. In fact, yes, it's already the right segment in the right bank. But if I add some other code before, and if I switch the bank before, it will not working. So it's always better to select the bank just before use it.
Ok, sì, si è calmato prima di
usarlo.
So I do it here, and I will do it here.
After I must restore the original bank.
Yeah.
I call my segment immediately before when I need to use. And And
After?
Immediately after, I must
No.
restore to
No.
the.
You do what you want, but my philosophy is, okay, I select a bank, I know it will always switch. So I think if I need anything from here, I set the right segment just before you use it. So after, I don't care. I don't care until I need to access another data. And in this case, I will switch again. So I don't have to worry about in which state it will be after. And those bank 0 and 1 will never switch, so I don't have to care about it. So for loading the palettes and loading the tile sets, I will also use segment 1 in bank 2. And now we will load the background data in different segments. So as we choose, it will be segment 3 and 4. Okay. How to do that? In fact, we'll export the data not at the include file. We could have a big include file and split into data table, but it's not convenient. So I added a new option. You can add what I call raw binary data to your mapper. I will show you. So I will export as binary, and I will select in which segment here I will put it. And I is bigger, it will span over 2 segments. So
I must pay attention if I want to create a new segment.
Yes.
To skip the segment.
It's why it's important to keep track of your segments. So now I know the next 3 one, it's go 5. Okay, so I will change to not create a header file but a binary file. In fact, you can select which kind of data you want. You have an option, but by default it's automatic. It will detect the formats according to the extension of the output file. So if I ask to create a .bin file, it will create a binary. If I ask for a .h file, it will create a header file. And if I ask for .asm, it will select assembler format. So it's enough. No. The build data. Okay. And now we have a bin file. There is one problem, not a very big problem, but this file have 2 tables. In fact, you have the tiles and you have the palette. I could just use an offset because I know the size of the image, but I think it's more convenient to keep the palette in another file. So I will use this file. This is a previous version where no, but not yes, background, and I just will remove this data and just keep the palette. Okay, so the palette will be in the other file, and the big pattern data will be a binary file. So we will include this here. So just for the palette. So the palette of the background will be in segment 1, and data will be in segment 3, I think. Pisa. I have to tell the compiler the palette exists, So I think it's BG palette. I think it's that. Okay. Yeah. Okay. BG palette. Okay. And now I will just duplicate this one. Okay. And that's the palette. So in this mode, it's a 16 color mode, 8 bytes per color, but you have 4 palettes. And you can select a different palette for the sprites and different palettes for the background, for the layer. One and other can use different palettes. So this is what I will do. So the 4 palette, I will use the first one for the foreground of the tile sets, the index one for the background, and the third for the sprites. So I will do 0 plus 1 and 16 plus 1. So index 16 is the beginning of the second palette, and as the first color is always transparency, I start copy one letter. So I will copy 50 colors from here, and here we are for the palettes. Now we have to include the data. So for do it, we'll use the configuration, because we have an option. I have an option. Okay. I will search for an example. I think VGM sample use it. VGM. Okay, this is this one. It's called raw files. It's just a list of the file binary file you want to add to your ROM. So I don't have it. Should be here. Interesting. Okay. Anyway, I think it should be here. And we will have only one file. The file will be put in segment 3. Okay. And the file. And the file is bg.b. Okay. We can. Okay, should be okay. And now we can display the contents of the file. The fine thing is we already. No, okay. Now we have a unique tiles on each cells of the layer B. So if we put your image as a tile set, it will be displayed as an image. So now I need this one. Okay. So now I will switch bank 2 to segment 3. Okay. And data will be a fixed address of the bank. It's this, because it's here from 800. But it will be the first part only. But let's start with the first part, because the second part is in the next segment. But let's copy 6 kilobits, 16 kilobits. Oh, okay, let's do the whole work. So, okay. I don't need 16 kilobytes, but I don't want to. Oh, big one. I didn't see it. Oh, okay. Cool. The start address will still the same because we switch the contents. The size is not, it will be smaller, but I don't want to make the maths. And the position when I want to copy is different because I want to put it after the first part. So edit
C'è l'offset da aspettare.
the size of one line. One line is 158. Okay, and the number of line is no. It's 60K in fact, because I copy 60K, so I put 60K on the screen.
Okay.
But this one is not that big. In fact, it's okay. Let's do the maths. Minus. This is the whole image, so it's about 24K. But we already copy 60K, so we can remove 60K. This is the remaining parts of the image. So here we copy 60K and copy the remaining. Is this okay? I hope it's still working. Starts. Okay, so it's for data. Warning is okay. It's because I use address as a pointer, so it's not happy. I can close with the casting. It should be happy. Oh, here we are. But I broke something. The palette is not the. Oh, okay. I don't copy to the right place. I have to copy to the pattern of the layer B. So we was looking at the pattern of layer B, but with the color of layer A. So it was not. What I broke you? Okay. You wait.
C'è la lettera.
And B. Okay. Okay. Should be big.
Good.
Not good.
No, good.
Okay.
The first.
I know why. This is because we have to tell the V99 to use the second palette for the layer B. How to do that? Just check the. Okay. I think there is a function to select palette. Cursor palette. No. It's in a P1 function. Okay. This is better. Okay. So this function to take two parameters. The first one is palette index of the layer A, and the second one is the index of the layer B.
Okay.
So 1
Okay.
and 2. So the first, so it's index 0, and the second is index 1. And now it should be okay. Okay, here we are. Okay. Do you want to take a break or do I continue? I can continue.
When I work, I begin at 7 in the morning, and
Or the
I
day.
can go until
I too.
midnight.
I too. Okay, so let's continue. So now,
Often the customer ask me, please, please. Because,
you have no aura. No, okay, no planning. So the next step is to display a level. Oh, display a level. I forgot. Perhaps we can start with sprites. Okay, let's start with sprites. So,
but sorry, before a question.
yes?
I seen the multi-segment with the data, but with the function, can I put a function in
Yes, sure.
another segment?
Yes.
Because I have some problem with this case.
Okay. Let's just for fun, we can put here. What? Okay, we create a function to initialize palettes, and we put all palettes in these segments. Okay. Initialize palettes. Okay. So I like to add comments. Okay. So basically, we will just have to copy this part. I will keep the segment setting here. And so you have to add some include, obviously, in a 90. I think it should be enough. Then I don't need the external. Should not. Okay. Okay. That should be enough. We have to tell the main program this function exists. Up. It's a definition, so I like to put it on the top. It's a function prototype. It's just to tell the compiler this function exists somewhere. And then I just have to be sure palette. Okay, let's put it here. Okay, so just select the segment where the function, the segment is located, and call your function, and that's all. Okay. This is a different story. So you have bucket call. In this case, SDCC, the compiler, will add bank switching just before the call. And so it's invisible for you. You just call your function and it's magic. But I think it's a very, very bad idea. It's convenient, but it's hide the switching of segments. So it's. I think it's better to have your plan what you want to put in what segments, and control the switching. It's very safer, or you will come to many bugs, I think. But it exists, it works. I can use it if you want, but I think it's not the way I think it's better. But let's try. By the way, it will not work with Neo 16 segments upper than segments number 254, because SDCC supports segments, 6-bit segments, but Blanchard call only supports 1 byte, so 8 bits. So it will work while you use segment number under 256. So it's one more, yes, but it's not the same limit that you can use in your program. So I don't like the way they did it, and in fact, even the SDCC team don't like the way the Blanchard call are handled, and they want to change the things, but now it's working, so they keep it as it's. Yes, I think it's better.
in modo esplicito fai Blanchard call.
Lo preferisco.
Però a questo punto anche per le funzioni si usano le switch del banco.
Sì, assolutamente.
Okay, so now it's the same thing, but using the function in the segments. It's the same thing, but with the function. Yeah. So it's work fine. No problem.
A me funziona. A me non funziona mai.
Okay.
Allora si è fatto la
Okay.
che si chiama
So let's go with sprites. Okay. So on the V990, the sprites work almost like the tiles. You put the data as an image, as a bitmap in the VRAM, and then you can select the pattern you want to display on your sprites, like on standard VDP. But the difference is we'll select 16 per 16 tile. Okay, so for example, this will be pattern 0, 1, 2, 3, and so on. So it's very, very, very convenient. I love the sprites on this card. So first we'll export the data. So like the others, just select the right file. We output as a header file. It's a small one, so sprites. Position is 00, and size is 32. Okay. Right.
Ah, quello sì, ma anche faccio, con per esempio faccio la stessa cosa, esporto e poi lo detto.
Sprite use the same system that tile for transparency. So color 0 will be always transparent. So you have 15 color. So I have to select the transparency color, and I will create a custom palette. And that should be okay. Oh, no. I was mistaken. Build data. Okay. And now I have, no? Okay. What? Shit.
Io mi sono usato quello, nel mio ho usato quello. No, scusa, io ho usato degli altri.
Okay, so we have our sprite data as bitmap, and we have our palettes. So I will take the two table for the external. I will need the sizes also, but it's the same size. So okay. External. Extend. It's the size. Oops. Okay, so it's in the same segment, so I can use the same switch. Perhaps we can do something more visual. I like to make it visual. For example, okay. Segment 1, data. Okay. This will be 3, 3, and 4. Okay.
Ma seguiamo la funzione che presente durante il segmento. Questo mi è capitato dove...
So, in fact, the sprites and the tiles share the memory. So it starts from 0, and this is all 4 tiles. So you have to tell the V990 where you have to find the sprite data. So for example, I use this function to tell where it starts. It's like with MSX VDP when you select the table address. And this is a copy, okay? Let's. Okay. Okay. I have to find the table name. Table is a sprite here. Okay. Okay. This is the address where I put it in VRAM, so it's the same selected here. Okay. And now we will display one sprite that use, for example, the first pattern. So you have function to under sprites. I can find an example here. Okay. So you have to use a structure. Okay, this structure tell where is what is the y value. So, for example, 100 x value 100. Oops. This is a pattern number. So from 0 to 25. Pattern index. This is a priority flag. It's interesting, in fact, on the V9990, you can tell if sprites are above everything or between the two layers of tiles. So, for example, you can have clouds on the front, then sprites, then the background.
Index, okay.
That's great. This is just a flag to disable the sprites. Okay. and this is a palette to use. So we will use the third one, so index 2. And so we have to load the palette. So let's do it in the segment code. Oh, I didn't include the sprites data. Oh, okay. So this is a font. This is the typeset. This is the background. And now the sprites. Oops. Sprites. Okay. And so we'll put the data in at 32, so the third palette plus 1. And the data is this one. Okay.
There is a parenthesis. The last parenthesis. The last row.
Oh, okay. Thank you. Oops. We should have a character, I hope. Yeah. Here we are.
Wow.
So let's do some fun stuff. We can start synchronize the gameplay. It's because if we want animation, we have to the animation to be always the same rhythm. So we have to synchronize. Currently, it just do many loops in one frame. So we'll create a new function called okay. I will create a function called update v90. Okay, it will be called every frame. Void. Okay. And this function will wait for synchronization and do some gameplay stuff. For now, just to check if it works. We will make this variable global, so we can modify this value anywhere. So let's function read only. I think the right place is here. Variables. Okay, let's call it player sprites. Oh, spruce. Sprites. Okay. And now we replace. Okay. And what I want to do is just to update the pattern. I have to change this. Okay. And I will just update the pattern and set the sprite again. So I will add a counter of frame to do animation. So variables, you 8 or 60s, frame counter. And by the way, I will add the boolean for synchronization. They think. Okay, the false. Do you know the difference when I set a value now or in the program? Yeah. Between setting a value directly when you declare your variable or setting it in your code. In fact, this way it's quicker and smaller. Okay. Okay.
It's quickly.
Yes, it's quicker, and in fact, all the variable you initialize this way will generate data with all the default value.
But I put the data.
Okay.
If I understand, if I put the value on the variable, is
Yes.
quickly.
Yes, quicker.
Because
The-
it doesn't put the data.
Yeah. This is faster and smaller than do it. Than do that.
Okay.
Because
veloce di chiave inizializzato rispetto a
this way,
inizializzato.
this way it's
Anche più poco meno.
yeah.
Ok,
You need more data and more instruction because this will be an instruction. But when you
More processor cycle.
yes, and when you declare here, it will create in your ROM an area with all the default value. And when you start your program, all those value will be copied in memory at once. So every variable will get the right value. So it's really cool. Okay, so we have our counter. And let's increment and use it at pattern index, for example. But we have only 32, perhaps 32. Okay. So each frame, each updates, it will show a different pattern. It should do. Okay, but it's too fast because we are not synchronizing. So now we had function waits e999 sync.
Wait, no.
Okay. And this function will just oops. Oh, that's not right. This function will reduce weights. No, not weights. While. Think it's not true. Oh no. Oh yes, not true. No, okay. I will set it to false. No. While sync is not coming, I wait. If there is only this function, it will hang forever. But hopefully we have the interruption that will occur and that will set the vsync to true. We can do it now. This is here. Okay. So when the vsync occurs, it's set to true. So it will interrupt my function. Oops. I reset to false for the next time, and I can increment my counter here. It's cleaner, I think. Okay. And now it should be slower. Still quick, but slower. It's because we change the pattern 60 times a second, so it's too much. We can, for example,
In base of VAL or
Base of the standard, video standard.
NTSC or PAL? Ah. For now, we don't handle anything. So I think it depends of the V9990. I suppose you can switch, but I don't know what is the default. But we could. Oops. I think there is something about synchronization. No. Perhaps. Okay. I think it's an option, but not available for all mode. It's why I did not make a general function, but you have some mode. You can see here, I think. This is NTSC.